refractive index of glass is 1.5. If the speed of light in vacuum is given as 3 into 10 power 8 meter per second, find the velocity of light in the medium. So here we have the refractive index is mu is equals to C by V. So that we can write as V is equals to C by mu. So the value of mu is given as 1.5 and the value of C is 3 into 10 power 8 meters per second. So if you want to find the speed of light in glass, so V is equals to 3 into 10 power 8 by the refractive index value is 1.5. So we are going to get the value as 2 into 10 power 8 meter per second. So therefore, the speed of light in glass is 2 into 10 power 8 meters per second. If refractive index of water is 4 by 3 and that of glass is 3 by 2, find the refractive index of glass with respect to water. So the refractive index of water is given here. So the refractive index of water is mu water is equals to 4 by 3 and the refractive index of glass is equals to 3 by 2. So we are going to calculate the refractive index of glass with respect to water. So refractive index of glass with respect to water is given as refractive index of glass upon refractive index of water. So this value is 3 by 2 upon 4 by 3. So this is 3 by 2 into 3 by 4. So the value is 9 by 8. So therefore, refractive index of glass with respect to water is given by 9 by 8. Speed of light in glass is given as 2 into 10 power 8 meter per second. Find the refractive index of glass. So refractive index mu is equals to C by V. So speed of light in glass V is given as 2 into 10 power 8 meters per second. And the value of C is 3 into 10 power 8 meter per second. This is the speed of light in the vacuum. So therefore refractive index of glass mu G is equals to 3 into 10 power 8 by 2 into 10 power 8. So therefore we are going to get the refractive index of glass is equals to 1.5. How does the refractive index of substance is affected by refractive index of the surrounding medium? So when light enters from one medium to another medium, so let us consider this is the medium 1 and let us consider this is the medium 2. So as the light is entering from one medium to the another medium, so here the refraction takes place. The refractive index of the particular substance is affected by the refractive index of the surrounding. It is not directly affected, but it is affected because of the change in the wavelength. Change in the wavelength of light. So let us consider the wavelength of light in this particular medium as lambda 1 and in this medium let us consider this as lambda 2. So if you are considering here the refractive index of the first medium, let us take as mu 1. But to the refractive index of the second medium, let us consider it as mu 2. So mu 1 by mu 2 is going to be here taken as lambda 2 by lambda 1. So in this manner, the wavelength of the light is changing in the particular medium as the optical properties of light change according to the medium. So this is how the refractive index of the particular substance is affected by the refractive index of the surrounding medium. What is refractive index, absolute refractive index and relative refractive index? So let us see first about what is refractive index. Refractive index is the bending ability of light in a particular medium. So it can be given as the refractive index mu is equals to, it is a ratio of sine of angle of incidence to the sine of angle of refraction. So refractive index gives about the bending ability of a light in particular medium. So refractive index is otherwise called as optical density also. So let us see what is this absolute refractive index. So when we just go with absolute refractive index, it is just take mu absolute. So you can define that as the absolute refractive index is the refractive index of a medium to the refractive index of the vacuum or free space. So when we take the ratio of the refractive index of the medium to the refractive index of the vacuum, then we are going to get the value called as the absolute refractive index. So let us see what is this relative refractive index. This relative refractive index. So whenever we are comparing the bending ability of light with respect to one medium to another medium, we are going to take the relative refractive index. So relative refractive index mu to 1 is given by the refractive index of the second medium with respect to the first medium. So it is mu 2 upon mu 1. So whenever we are comparing two media, we are going to take this relative refractive index of the second medium with respect to first medium is given by the ratio of refractive index of the second medium to the first medium. For example, if we want to consider the relative refractive index of glass with respect to air, so we are going to write mu. For example, we are going to write it is mu Ga. It is refractive index of glass by refractive index of air. So this is going to give this value as the relative value. So it is relative refractive index of glass with respect to air. So let us see, refractive index is nothing but mu is equals to sin I by sin R. So it is the bending ability of light in a particular medium. So it is also called as optical density. Absolute refractive index is nothing but it is the ratio of refractive index of the medium with respect to vacuum. Relative refractive index is defined as the refractive index of the second medium with respect to first medium, or one medium with respect to another medium. So this is relative refractive index.